All right, welcome back, everybody. We're going to be continuing with our exploration of quadratics by focusing in this section on what the graph actually looks like and how do we actually get the graph and how do you know if you have a table of values that you're even looking at a quadratic relationship. So today you're going to be using the online program called Desmos. So it's desmos.com. That's where you're going to go on your tablet, your laptop, even your phone, although it's not the best on your phone because it's too small. And we're going to generate a table of values like you see here. We're going to fill it in, and I'm going to explain to you what these other columns are in a second. And then we're going to get the picture, both from Desmos and by hand. I don't want you to become reliant on Desmos. You need to know how to be able to generate this material without the computer. But the computer offers you an opportunity to check your answers and to look for relationships a little bit quicker. So let's get started with this first one. We're supposed to graph y equals x squared. Okay, so that's the first relationship we're supposed to graph. And we're not going to go to Desmos right away and type it in. Actually, we're going to fill in the table of values. So you see the x's are already filled in for us. -3, -2, -1, 0, 1, 2, 3. We don't even go sometimes as low as -3 and +3. Normally it's just -2, -1, 0, 1, 2, normally. So we did a little bit extra here, so our table's a little bit longer than it would normally be, because 5 points is really all you need to get a pretty accurate graph. Then you see in the y column, I've already taken the equation that says x is supposed to be squared, and I've inserted the x number. And then I was doing to it what was being done to x. So in this case, I was squaring it. So remember that y equals x squared. So the y value is whatever the x value is squared. Notice I'm using brackets. Brackets are important because the negative that goes with the 3 means the negative is being squared along with the 3. Okay, that's what the bracket means. So it's negative times negative 3 times 3. So underneath, I'm just going to say 9, right? That's what -3 all squared means. -2 times -2 is +4. -1 times -1, right? -1 squared is +1. 0 times itself is 0. 1 times 1 is 1. 2 times 2 is 4. All the way down to the bottom, 3 times itself is 9. Okay, so we have our table now filled in for the y's. So what this gives us now are our points. So what does this mean? Right? 0, 0 is a point on the graph. -1, 1 is a point on the graph. -2, 4 is a point on the graph. -3, 9 is a point on the graph. 1, 1, 2, 4, 3, 9. Okay, so that's what that means. Those are points, right? This is the x, this is the y. Now we could just plot those points and attach them. So we'll do that in a second. But I want to explain to you what these next columns mean and different labels we could have. So right now it looks like it's a triangle with an exponent of 1 on it. This is a fancy way of saying first differences. And the common way to say that is our delta y's, our change in y's. That's what that column means. So in grade 9, you learned that after you have your x and your y column, you can add another column called your first differences or your delta y's, your triangle, which means D for difference. And remember, this is y2 minus y1. It's the y value below. So when we group the first two y values, it would be 4 subtract 9, not 9 subtract 4. It's the one below minus whatever the one above happens to be. The next combo would be 1 subtract 4. The next combo would be 0 subtract 1. The next combo would be 1 subtract 0, then 4 subtract 1, and then 9 subtract 4. So when we get our answers here, 4 subtract 9, right, is -5. 1 subtract 4 is -3. 0 subtract 1 is -1. 1, 3, 5. Right? Those are our answers. Notice they are not the same answer. And because they didn't work out to be equal, the same number, we know that these points don't make a line. This isn't a linear relationship. Okay, so if the square didn't give it away, now we know for sure it is not a linear relationship because the first differences are not equal. Then this is new, we can add another column after that. And again, it has the triangle with an exponent of 2. So what this one is now referring to is second differences. And like you probably guessed, if first differences are change in y's, this is our change in y's. So delta delta y. Some people just put the delta with the exponent 2 on it. So all of these things mean the same thing. It's our second differences, which means we are now going to group our answers from the previous column. And now it's the number below minus whatever the number above happens to be. The number below, -1, minus whatever the above number happens to be. The number below minus the number above. The number below minus the number above. The number below minus the number above. So now we have to go through and we have to answer these. -3 plus 5, right? Negative makes a plus. So -3 plus 5 is 2. -1 plus 3 is 2. 1 plus 1 is 2. 3 take away 1 is 2. 5 minus 3 is 2. Notice 2, 2, 2, 2, 2. Notice the second differences are all equal. That's the first thing you got to notice. So that's telling me that this graph is going to be a curve, but a very specific type of curve. So this relationship is quadratic. So not linear, quadratic. The shape, the points will make, is called a parabola. So a parabolic shape, which is like a U shape. So let's go back and actually plot these points and see what it actually looks like. So -3, 9, -3 on the x, 9 on the y. So roughly there. -2, 4, -2 on the x, 4 on the y, approximately there. -1, +1, 0, 0, 1, 1, 2, 4, 3, 9. Notice the symmetry. This is important. Notice the same height on either side. So it's like the graph there's a mirror. And in this case, the mirror would be the y-axis. So to do this smoothly, it's hard to start up here and to go around. So I would start down here at the 0, 0 point. And when you're at the 0, 0 point, just attach going up through one arm as best you can. And then attach the other arm. Again, starting at 0, 0, going up the other way. I find that's how you get the smoothest, most accurate curve instead of starting high, trying to eyeball it and come back up again. So this is y equals x squared. Notice, again, just like we do with lines, we put arrows at the end of each of the arms. That's because the arms keep going on and on forever. Just because I only went as low as -3 and as high as +3 doesn't mean the graph stops there. It actually doesn't. This U shape is what I mean by parabolic. It's symmetrical, right? Looks like we're at the same height here, the same height here, the same height. There's like a mirror line. Like I can fold the page and have one arm sit on top of the other arm. Like you can see it, my pen through the page, if I fold it along the y-axis. So the y-axis is actually acting as the mirror. And we call that the axis of symmetry because that seems to be where the points are aligned off of. Notice that it's a U shape, that it seems to be opening in a direction we call up, right? The U is opening up. So when we actually now go through our analysis here, down at the bottom, we're going to point out some characteristics of this graph. The direction of opening, we would say up or upwards. both mean the same thing, so you can pick either. So it does open up, and we would know that because the second differences were all positive. So the graph or the parabola will open upwards since the second differences, delta delta y's, are positive. So think of positive as smiling, as being optimistic, and the parabola opens upwards. Now, the equation of the axis of symmetry. We use A of S just to short form axis of symmetry. This is the symmetrical line that divides the graph into two equal halves. So I already said we know it's the y-axis, right? The y-axis is the folding line. Now it wants the equation though. So the equation of the y-axis is a vertical line. So because it's a vertical line, it's going to start with x equals. So x equals whatever number it happens to be touching at. Well, x equals 0 is the name of the axis of symmetry, the y-axis in this case. So again, vertical lines start with x equals, and they're named after whatever number the line touches through on the x-axis. So x equals 1 if it was posted over here, x equals 2 if it came down through here, x equals 3 if it came down through there. The y-intercept, so you guys know this. This is the value of y when x is 0. So when x is 0, what is y? Y is 0. So 0, 0, or y equals 0. Your choice as to how you want to state it. You can state it as like a location, like there, that's the y-intercept, or you can state it as what the y value is worth when x is 0. Now the coordinates of the vertex, this is a very important keyword. So this word vertex, this is the most important point on a graph. Okay, so this is where the graph changes direction. So a turning point. So changes direction. I call it the bum. So you see here how it's coming down, coming down, coming down, coming down, and then all of a sudden starts to come back up again. That guy. That's where he decides to change it around. So that's the last point in which he was still going down, but is now coming back up. So the coordinates of the vertex in this case would be 0, 0. And it's given as coordinates, right? So it's x, comma, y. It's always the x number first, just like any coordinate. So on our graph, I'm going to label these so you guys can see. That is the vertex, which is 0, 0. The axis of symmetry, if you want to picture it, there's your mirror line. It's the equation, x equals 0. We call it the y-axis for short, but it's that equation. And that's also the y-intercept over there as well. Anything else? Oh yeah, they want to know things like, what are the x-intercepts? Well, in this case, the x-intercept is also the vertex. So this is when y is 0. That's when you get x-intercept. So where does this graph touch the x-axis? Well, he only touches at that one point. So he touches at x equals 0. So not very interesting for this graph. He only has the one x-intercept. As you can see, the graph has two arms. So he has the potential of actually touching the x-axis in two spots. But in this case, he only touches in the one spot. So let's now think about, does he have a maximum or minimum value? And state whether it's a max or min. So this is now where we're getting back to the opening up or down. This guy opens upwards. So does the graph have a peak, which means he doesn't go higher than the number, or does he have a bottom, a minimum, where he never goes below that level? In this case, because he opens upwards, he has a minimum. He never goes lower than where the vertex is. So the vertex, in this case, the y value is the maximum or minimum value. In this case, it's the minimum because this graph opens upwards. All right, so that means this guy has a minimum. So he has a minimum of 0. So it's the y value of the vertex. It's the lowest this graph ever goes. He never goes below that height of 0. Do you notice anything about the second differences? We already mentioned they are equal. They are positive. So the fact that they are equal means it's quadratic. It's going to make a parabola. The fact that they are positive means that the parabola is going to open upwards. How would you describe the shape of the curve? Well, it is symmetrical. And it's a U shape. People tend to describe it. It's not a V. It might look like a V down here at the vertex, but technically it's not a V, right? It's more U. And this graph can change in its width, which makes it look more like, say, a satellite dish or a cereal bowl. So this graph can be very U-like. This one just happens to be a little more, what do you call it? V, like a little more pointy at the bottom. So now let's continue going forward with these other ones, because that one was very basic. That is what we call the first or parent graph, y equals x squared. Those points are going to become second nature to you, 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Those basic 5 points that made the last shape, those are points you're just going to know. However, the graph is not always just going to be y equals x squared. This one is y equals x squared minus 6x plus 5, which means to get our y values, we're going to have to do some work. So we're going to have to plug in all these different x values. Notice the x values are 0, 1, 2, 3, 4, 5, 6. Okay, those are our x values. So whatever x is, we're going to have to square it and then minus 6 times that x value plus 5. Okay, that's what we need to do in order to get y. So remember, y equals whatever x is squared minus 6 times x plus 5. So let's work it out. I have just inserted the x values in. I would suggest you pause the video. You go through each one on your own, insert them, figure it out, use a calculator if you need to, and then unpause and then come back and check your answers with mine. All right, so I'm going to insert 0. 0 squared is 0, minus 6 times 0 is 0, plus 5 is just 5. So 0, 5 is a point on this graph. There we go, 0, 5. Then 1. 1 squared is 1, minus 6 is negative 5, negative 5 plus 5 is 0. 1, 0 is a point on this graph. 2 squared is 4. 4 minus 6 times 2 is 12. 4 minus 12 is negative 8. Negative 8 plus 5 is negative 3. So 2, negative 3. 2, negative 3 is around there. 3 squared is 9. 9 minus 18 is negative 9. Negative 9 plus 5 is negative 4. So 3, negative 4. 3, negative 4. You notice how the points get closer and closer together? That's telling you you're getting closer to the vertex. So my guess is this is either the vertex or the vertex is coming. 4 squared is 16. 16 minus 24 plus 5 is negative 3. Now notice we're starting to see symmetry. I had negative 3 as an answer before. So positive 4, negative 3. See the symmetry of the point? They're at the same height. So that tells me this is the vertex, most likely. So I'm expecting this one to be 0, and I'm expecting this one to be 5. So 25 minus 30 is negative 5. Negative 5 plus 5 is 0. So 5, 0, right? Symmetry. And 36 minus 36 plus 5 is 5. So 6, 5. 6, 5. Now I could have just known, again, if I wanted to cheat a little bit, without even doing the last few points, that this one would have to be the same distance away from the mirror line on this height. This one would be 2 away, 2 away, 1, 2, 3, 1, 2, 3, 6, 5, 6, 5. Okay, so I'm just showing you the symmetry can be used to help you graph these guys, because once you get one arm, then the other arm is just the mirror image, right? So again, smooth curve, arrow, smooth curve, arrow. All right, let's go do our first and second differences, and then we'll do our analysis. So again, our first differences, 0 minus 5, me showing my work, is negative 5. Negative 3 minus 0 is negative 3. Negative 4 minus negative 3 is negative 4 plus 3 is negative 1. Negative 3 minus negative 4, that's why it's helpful to show your work so you don't get confused with the integers. Negative 3 plus 4 is 1. 0 take away negative 3 is 3. And 5 minus 0 is 5. These are not the same numbers. So that means this is not a line. As we can plainly see, it's not a line. It's not linear. Now we're going to do our second differences, our delta y's squared. So again, it's our differences of our first differences. So negative 3 minus the negative 5 sitting above it is negative 3 plus 5, which is 2. Negative 1 minus negative 3 is also 2. 1 minus negative 1 is also 2. 3 minus 1 is also 2. 5 minus 3 is also 2. Now, they're not always going to work out to be 2, but they will always work out to be the same number. Now, notice again, positive. This guy opens up. Okay, so that we kind of knew. These were going to work out to be positive. So the direction of opening, we can now answer these a little bit quicker. So the direction of opening down here at the bottom is upwards or up. The equation of the axis of symmetry. X equals, oops, why did I put 0? X equals whatever number he crosses at. X equals 3 in this case, because that's the number he cuts through on the x-axis. So that's our mirror line. The y-intercept is whatever the y value is when x is 0. So 0, 5. According to the table and according to the graph, 0, 5 is a y-intercept. The coordinates of the vertex, right, which is right there, the bum, the change of direction, 3, negative 4. So again, pay attention to some patterns here. Notice that the axis of symmetry is the same number as the x value of the vertex. Okay, so x equals 3, right, was the axis of symmetry equation. That number comes from the x value of the vertex. They will match. Again, top of the next page, 0. Now this guy has 2 x-intercepts. He crosses here, 1, 0, and he crosses here at 5, 0. So 1, 0, 5, 0. So whenever we get a y value of 0, that is an x-intercept. Whenever we have a y value, a height of 0, that means we're sitting on the x-axis. So that's a y-intercept. So those are our 2 x-intercepts. This is where those 2 arms touch the x-axis. We could state it as x equals 1 and x equals 5. So you can state them like that as location, as x is worth those numbers, or as locations. So coordinates, right? So we could state it as 1, 0, and 5, so those are locations. So you get to pick whether you want to state them like this or like this. They mean the same thing. Does he have a max or a min? Well, he has a minimum because he opens up. And again, the minimum is whatever the lowest height is. And in this case, the vertex goes all the way to negative 4. That's the lowest this graph ever goes, this height. Whatever that height is. So this is the minimum value, which would be negative 4. Do you notice anything about the second differences? They are equal and positive. How would you describe the shape? Parabolic. So U-shape and again symmetrical. Okay, so hopefully you're seeing some patterns here arising. Now for the next ones, in order to save some time, again, you should pause the video because now we have a different equation for the third one. So I think there's 5 in total. Yep, 3, 4, 5. So I've gone ahead and I've actually filled in my y values. I did the work, and you can see I just did it on the side here so that I'd have more room. So I inserted positive 1 into the equation and I worked it out. I inserted positive 2 into the equation. Now they gave me the x values, 1 through 7. So those were the numbers I used, and out popped the y values. Those were the numbers I inserted here. So you need to be able to go and do the same for yourself. Notice the negative is in front of the x squared, but the negative is not being squared. So when you sub in 1, this is 1 squared, which is 1, but with now a negative sign in front of it. 8 times 1 is 8 minus 10. So this is negative 1 plus 8, which is 7. 7 minus 10 is negative 3. Okay, that's what that negative in front does. He's just going to fall in front of whatever answer you get after you square. He falls in front of whatever you get after you square the x. Okay, so again, pause, then come back, check your answers with mine. I'm going to do my first differences, and then I'm going to do my second differences. So 2 minus negative 3, right? Bottom minus whatever the top number happens to be, is 5. 5 minus 2 is 3. So right away, they're not matching. 6 minus 5 is 1. 5 minus 6 is negative 1. 2 minus 5 is negative 3. Negative 3 minus 2 is negative 5. Well, I'm seeing some symmetry, but the signs are all reversed. 3 minus 5, let's get our second differences, is negative 2. 1 minus 3 is negative 2. Negative 1 minus 1 is negative 2. Negative 3 minus negative 1 is negative 3 plus 1, which is negative 2. And negative 5 minus negative 3 is also negative 2. Notice they're all the same number again. I don't care what number they worked out to be, but the fact that they're all the same tells me that this is going to be a parabola. Notice that they're all negative this time. So that's probably going to give you a hint as to the direction you think this graph is going to go. So I'm going to plot my points. 1, negative 3. So positive 1 on the x-axis, negative 3 on the y is here. 2, 2. 3, 5. And again, we go to 4, 6, 4, 6. And then we come back to a height of 5. Right? So you see symmetry. These ones go together, then these ones go together, then these ones. So that tells me this is the vertex. So 4, 6. So right away, I already know my axis of symmetry is here. And again, I could cheat and just say, oh, that's the same height at the same distance away, the same height at the same distance away. Say if I didn't have the rest of the points down here. Okay, so if all I went to was 4, 6, I'm like, oh, then I know the next one is going to be 5, 5, and I know the next one's going to be 6, 2, and 7, negative 3. So right away, again, start at the vertex, nice smooth curve down, start at the vertex, nice smooth curve down. Okay, so again, he looks the same but different than the last ones. That is our vertex. Our bum is up in the air. The vertex happens to be 4, 6. The axis of symmetry is x equals 4, whichever number we're at when we change direction. So this one's getting a little messy for the rest of them. So I'm going to show you on Desmos how we come up with some of our other answers. But those were easy ones. The vertex and the axis of symmetry are easy to read off the graph. So the direction of opening in this case would be down or downward. The equation of the axis of symmetry, x equals 4. The y-intercept, we're going to get it off Desmos because right away, I don't know when this arm, it's going to be this arm that's eventually going to come and cross the y-axis. I don't know where. It's going to be here, it's going to be here, it's going to be here. We'll get that answer off the computer. Coordinates of the vertex, that I know, 4, 6. The x-intercepts, well, is that 1.1, 1.2, 1.3? Is that 6.5? So again, we're kind of guessing for the x-intercepts. It says 2 decimal places. So we're going to say off Desmos. We're going to get our answers for that one. Does he have a max or a min? Well, in this case, he has a maximum. And the maximum, right, because the bum's up in the air, is going to be whatever the maximum height is that he never goes above that level. So he has a max of 6 in this case. So this parabola never goes above the height of 6. There'll never be graph over here, right? Because he came up and then he changed direction and went down, and that's it. That's all he's ever going to do. Okay, so let's now go to Desmos. We're going to rely on our graph. So when you go to desmos.com, you're going to go to desmos.com. You're going to go to Graphing Calculator. And then on the side here, it's going to pop up. And it's going to let you type in your equation. So, of course, I need to see the equation. So we're going to type in the negative. So right here, our negative sign. I want to make sure I use the proper negative sign, not subtract. Maybe it doesn't even care. All right. Yeah, I don't think it even cares. Negative x squared. So in this case, they let you use the subtract sign as negative. So what I'm doing is I'm negative x, and then the a squared, there's your square, plus 8, and then x, and then minus 10. And there's our graph. Now, that's pretty good. I'm going to take that down so we can see more. We can zoom out. We can zoom in, right, depending on what we want. So you can change your scale too if you want. So right away, as soon as I touch on a point, there's our vertex. You see how it gives me the exact coordinates? But we already knew that one. We need to get our y-intercept, right? That was the first thing. So we follow the arm, there it is. So as soon as you touch it, what is the y value when x is 0? The y value when x is 0 is negative 10. So that is our y-intercept. So off Desmos, 0, negative 10, because I wouldn't have gotten that off my graph, right? My arm wasn't that long in order to come down like that. So that part's done. But now we have to get the x-intercepts. So now you come back up. And again, you can zoom in if you want. Well, I'm not going to guess. I'm just going to touch it. So what is the x value when y is 0? 1.55. It says 2 decimal places. So x equals 1.55 and x equals that number, 6.45 if we round. Okay, so those are our 2 x-intercepts right off Desmos, those 2 numbers. Again, 1.55, 0 in brackets, 6.45, 0 in brackets. That's basically it. So that's what Desmos allows us to do, is to get those yucky answers very easily. Now, if you wanted to see the table of values, you would go to this settings little menu here that looks like a flower, and you would pick the first icon, which is a chart. And here are your numbers. So negative 2 goes with negative 30. Negative 1 goes with negative 19. 0 goes with negative 10. 1 goes with negative 3. And you can scroll up and down, I believe, your chart, usually, or you can add more numbers. Like I can say, oh, what if I subbed in x is 7, and it pops up the y value that goes with 7. So I can put in whatever x values I want, and it'll give me the y value. So you don't actually have to do this work that we did on the side here, because it does it on its own. Now, do you notice anything about the second differences? Again, they are equal and negative, hence why the guy opens down, hence why he has a maximum in this case. When you're negative, you make a frowny face. You're upside down, which means you have a max. How would you describe the shape? Upside down parabola. probably the way most people would describe it. It's still symmetrical. The only difference is he's opening upside down. Okay, the last two, again, get into the habit of knowing how to sub in these numbers into this equation. This time, the equation is negative 2x squared minus 12x minus 9. So you can see I subbed in negative 6. So negative 6 squared is positive 36. Positive 36 times negative 2 is negative 72. Negative 12 times negative 6 is positive 72. So these two guys pretty much cancel each other out. And then minus 9. So that's how I got minus 9 here. And then I did the same thing for negative 5. I subbed that in and I worked it out. And then I subbed in negative 4 and then negative 3. So you're supposed to be able to go through and do this for yourself. And then, of course, we'll get our first differences and we'll get our second differences. Showing my work so I don't screw up on my integers. 1 minus negative 9 is 10. 7 minus 1 is 6. 9 minus 7 is 2. 7 minus 9 is negative 2. 1 minus 7 is negative 6. See, same number, wrong sign. Negative 9 minus 1 is negative 10. Instead of positive 10, negative 6, still positive 6. So there's definitely symmetry there, but they're not the same, so we have to go through and we have to continue on now with the next column, which is our second differences. 6 minus 10 is negative 4. 2 minus 6 is also negative 4. Negative 2 minus 2 is negative 4. Negative 6 minus negative 2 is negative 4. And negative 10 minus negative 6, negative 10 plus 6 is also negative 4. Notice they all worked out to be the same. They all worked out to be negative. They all worked out to be 4. So when I go to plot my points, I'm going to get a graph that looks like this. And you could probably guess which one is the vertex, just based on symmetry again, in the y values. So negative 6, negative 9, roughly. It's kind of hard to do it without a grid in the background, so try your best. Negative 5, positive 1. Negative 4, positive 7. Negative 3, positive 9. Negative 2, positive 7. Negative 1, positive 1, of course, same height. And then this one would be 0, negative 9, same height. So this guy is long and skinny. There's one arm. Oh, I kind of missed that one. Maybe I'll try him again. I didn't do a good job on that one. I know I had to come out a little bit wider because I'm supposed to be touching the y-axis over there. All right, so let's try this again. So yeah, if one of your arms doesn't look right, please erase it. And of course, you're doing this in pencil, as you should all your graphs. There we go, that's better. Because I can definitely see that's the y-intercept right there. So again, my axis of symmetry cuts through right there. So my A of S is x equals whatever that number is, negative 3. My vertex is negative 3, height 9, which means 9 is my maximum value. This graph never goes above a height of 9. So as you can see, that's the highest this graph will ever go. The X-intercepts are hard to see, so I can't label those. Those are probably decimals, so I'll have to get those off the computer. The Y-intercept is negative 9, so I know 0, negative 9 is the Y-intercept. And that's basically all I can label at this point. So, direction of opening, downwards or down, equation of the axis of symmetry, x equals negative 3. The y-intercept, I can just steal that right off the table, 0, negative 9. The coordinates of my vertex were negative 3, 9. The x-intercepts, I have to get them off the computer to 2 decimal places. and then the max, we had a maximum of none. All right, so let's type this guy in. So back to here. I'm going to go back, so I just X that one. I don't want that graph anymore. I'm done with him. So now let's enter a new graph. So there's my keyboard again. So I need negative 2x squared, negative 2x squared. Notice as soon as you put the square on it, it becomes a parabolic shape. See, without that square, so if I get rid of the square, it's a line, but as soon as I put a square, it's a parabola. Negative 2x squared minus 12x minus 9. Okay, so right away I don't even see anything, so I have to kind of move him around. There he is. So that's what we just got in our own picture. But there's our Y-intercept right there, so we got that. There's our vertex right there, we got that. So we're all good with those points. We could read those off our graph, but what we couldn't read was this point and this point. X-intercept, X-intercept, because the Y value is 0. So negative 5.12, that's one of them. So negative 5, so X equals negative 5.12, and X equals, what's the other guy called? Negative 0.88. Negative 0.88, because again, it only wanted 2 decimal places according to the directions. Okay, so if you called it negative 0.8709, okay, but it wasn't asking us for 3 decimal places. Do you notice anything about the second differences? Well, the second differences were equal, and they were negative. Second differences are equal and negative. How would you describe the shape? Upside down parabola. And again, parabola means the U shape. Okay, so now to show you even quicker, so we're not even going to do any of that work anymore. So I still did it on the side. This is the 5th and final one. So this equation is 3x squared plus 24x plus 48. So again, each time you got to insert the new x value, you got to work it out. So again, pause the video, make sure you were able to do this, and then come back and check your answers again with mine. And you'll know if you're right, because again, you should see symmetry, right, in your y values. You should see symmetry going down your page. Now, I'm going to just cheat a little bit. I'm going to go right up to my decimals. I'm going to type in 3x squared plus 24x plus 48. Now these are big numbers. There we go. There he is. Now to fill in my table again, I go to the settings and I go right there. So I need certain x values. So I need negative 7. So negative 7. Did I type this in right? 3x squared plus 24x plus 48. Thank you. I missed the 48 part. I was going to say this doesn't seem right. There we go. That's better. So when you type in negative 7, you should get 27. I'm going to change this to negative 6. So this is what it was trying to tell you. You should get 12 when you do that. When you type in negative 5, again, this is for people that don't want to do the math on their own. You could type in negative 4, you get 0. When you type in negative 3, you get positive 3. When you type in negative 2, you get 12. And you type in negative 1, you get positive 27. So here's the table of values. That's exactly my table. So I know I did this right. We'll come back to this guy in a sec. I'm going to plot my points and do my first and second differences. So my first differences, my delta y's, 12 minus 27 When you do that, you get negative 15. 3 minus 12, negative 9. 0 minus 3, negative 3. 3 minus 0 is positive 3. 12 minus 3 is positive 9. Again, same number, opposite sign. 27 minus 12, oops, that's minus sign, is positive 50. Then, the next column, delta, delta, y, since those didn't work out to be the same, we've got to add the next column, negative 9 minus negative 15. Negative 9 plus 15 is 6. Negative 3 take away negative 9 is negative 3 plus 9, which is 6. 3 take away negative 3 is also 6. 9 minus 3 is also 6. 15 minus 9 is also 6. Notice they all worked out to be positive. They all worked out to be 6. So when I go to plot this, negative 7, positive 27, roughly there. Negative 6, positive 12, roughly there. Negative 5, positive 3 here. Negative 4, 0 here. Negative 3, positive 3. Yep, there's our vertex. We're coming back around again. And then this height of 12 should be over here at negative 2. And this height of 27 should happen again at negative 1. Again, start below, smooth arm up, start below, smooth arm coming up. There's my picture where I plotted those points. He opens upwards, which I expected because my second differences were all the same. Here's my axis of symmetry where my vertex is located. So the axis of symmetry, my A of S, is x equals whatever that number is, negative 4. My vertex is negative 4, 0. And this guy has a minimum, right? He bottoms out. He doesn't go lower than that height. So what we're going to do now is we're going to answer these questions again. Direction of opening is upwards. The equation of the axis of symmetry is x equals that number, which is the x value of our vertex. The vertex is negative 4, 0. The y-intercept, I don't know. I'm going to have to extend this arm. Eventually, it's going to come and cross through the y-axis, but right now, I have no idea. So I have to get that off the graph on the computer. The x-intercept, this guy has one arm touching at negative 4, 0. The other arm also touches at negative 4, 0. So both arms touch at the same point. Happens to be on the x-axis, so that's your x-intercept. X equals negative 4. Remember, you can say it as negative 4, 0. So he only has the one x-intercept. You can state it twice, but really it's only one answer. He has a minimum, as we said, because he opens upwards, and it is a height of 0, right? A minimum height, minimum value of 0, and then he goes back up again. So I have to look on the graph in order to get my y-intercept, because I wasn't able to get that off my picture, wasn't good enough. So as we scroll up, where are we? There we go. Whenever x is 0, whatever the other number is your y-intercept. So it crosses at positive 48, which was off my grid. I don't even go up to 48. So 0, 48, and that was off Desmos. Because, yeah, there's no way I would have gotten that graphically. I can get it algebraically by working it out. And I'm going to show you later where I knew what that number was, because you've probably seen this 48 somewhere else in the equation. So there's definitely clues as to what the y-intercept is. So we got the x-intercept, we got the y-intercept, we got the minimum. Do you notice anything about the second differences? They are equal and positive, that's why he opens up. So because they're positive, he opens up, it has a minimum. How would you describe the shape? Again, symmetrical, parabolic, that U shape. Okay, so now we're going to summarize everything now from all of these 5 examples in one location. Okay, so we're going to try to put some of these patterns together so we're not always relying on decimals to get our answers, because there's other quicker ways for us to do this. So the degree. Now this is talking about the word degree. You may not remember that, but the degree is the highest exponent in the equation. So if you look back through all of these examples, what was the highest exponent you saw in the previous one? The one before that one, what was the highest exponent? What was the highest exponent? So if you look at all of these examples, what do they all share? The degree of any relationship that looks like this, which is what they all look like, is 2. So we call this a second degree. It's a second degree relationship because the highest exponent is 2. And that means the graph of a second degree relationship will be quadratic with a shape that is called a parabola. Okay, so second degree equations where you see the highest exponent is 2 means they are quadratic. Quadratic graphs are in the shape of a parabola. The maximum or minimum value of a quadratic is also called the optimal value. So if you don't want to say whether it's a max or a min specifically, but you want to refer to it, then you can just call it optimal. Optimal could be a maximum, optimal could be a minimum. The optimal value of any quadratic is the blank coordinate of the blank. So you already saw this. It's the y value of the vertex. It's this number of the vertex, right? All right, so if the second differences, which are constant, are positive, then the graph opens up. If the constant value of the second differences are negative, then the graph opens down. So we saw that over and over again. Now, let's see now if you made this relationship. Now it's talking about the number in the front of the x squared, if it's positive, versus the number in front of the x squared if it's negative. Okay, the number in front, this is the third one that we did. The number in front of the x squared was negative. Which way did it open? Down. The number in front of the x squared is negative. Which way did it open? Down. The number in front of the x squared is positive. Which way did it open? Up. And you'll see that continues for the other two as well. So if the number in front of the x squared, the a value, is positive, then the graph opens up. And if it opens up, then it has a minimum. If the value in front of the x squared, the a value, is negative, then the graph opens down. So therefore, by default, it has a maximum. Bum is in the air. And bum, remember, means vertex. The vertex lies on the symmetry line, right? So the vertex, up in the air or down at the bottom, it doesn't matter, lies on the axis of symmetry. It's always x comma y. Now, we don't just call it x comma y because anything is x comma y, right? Like any point on the graph is x, y. This is a very particular point. It's the most important point on a parabola. So we don't just call it x and y because this is an xy point, 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 that's an xy point. So to make it stand out and be different, we actually give it specific letters h and k. So h is where the x number goes, k is where the y number goes. So we gave it very specific letters because it's a very particular special point. Everything is xy. This is still xy. But if you want it to stand out or you want it referred to it because it's specifically the vertex, then you would call it h and k. So h comma k. So the vertex lies on the axis of symmetry. If the coordinates of the vertex are hk, then the equation of the axis of symmetry is x equals h. And then the k value is your max or your min. Right, the y value of your vertex. which in this case is represented by k. So h and k are just x and y. But because they're the vertex point, they're even more special with the different letter designation. The axis of symmetry is the blank of the segment joining any 2 points on the parabola that have the same y values. So what this axis of symmetry is if you pick any 2 points that have the same height and you connect them. So I'll do it here. I connect them. This axis of symmetry is the perpendicular bisector. Perpendicular bisector. Perpendicular means it hits it at 90 degrees, and bisect means cuts it in half. Perpendicular bisector, which just means each point is at the same height on either side of the mirror line, the axis of symmetry. That's all that means. Okay, so the 2 points have the same y coordinate on either side of the mirror line. That's what we were looking at, right? Same height, same distance away. Now this one's not, I didn't graph that one very well, so let's look over here. So again, same height, same distance away. Same height, same distance away from the mirror line on either side. That's all it's talking about. Now, if the parabola crosses the x-axis, so if the arms touch the x-axis, the coordinates of these points are called, as you already know, the x-intercepts. Right? Those are called x-intercepts. We already know that. This right here, as we know, is the y-intercept, which is 0, y. Axis of symmetry, we know, is the dotted line that goes through. So whatever the x value of the vertex is, that's what's used up here. And this one has a max value of k, whatever the k value is of the vertex, meaning the y coordinate. The x-intercepts x1, x2, whatever those numbers are that it touches at. Make sure you put arrows on your parabola. I just included the y-intercepts. We have our axis of symmetry. We have our vertex. What else is important? We already know symmetry, so whatever height this point is directly across will be at the same height. Right? Because that's what symmetry means. This is the mirror line. So this is exactly half the graph. The other half is on the other side. Okay, right here, something you may have noticed. The value, the relationship between the a in the equation y equals ax squared plus bx plus c and the value of the second difference. Okay, so maybe you didn't notice this, but you notice here our second differences were negative 2. Negative 2, negative 2, negative 2. What was our a value? Negative 1. Okay. Here, our second differences are 6, 6, 6, 6, 6. What was our a value of the equation? 3. So there's a relationship there. How does 6 become a 3? Let's get another one. Our second difference is in the fourth case, negative 4, negative 4, negative 4, negative 4. What was our a value? Negative 2. How does negative 4 become a negative 2? So if you're thinking, well, we just take our second differences and divide by 2 and we'll get the a value, then you're correct. That seems to be the relationship here. So our a value is a is equal to our second difference is divided by 2. Or a more common way, if I put the 2 on the other side, 2a is equal to our second differences. So if you want to know from your second difference table what your a value is, you set up this little mini equation and you can rearrange and get a because you've already figured out the second differences. So if the second differences are 6, you're going to put 6 here. 2a equals 6, that means a equals 6 divided by 2. The a value must be 3. So you know there was a 3 at the front of that equation. Okay. The degree of a polynomial, yep, is a single variable at the highest exponent. So that's what the word degree means. So the degree of a quadratic is 2. You already know it's a second degree relationship. This is why you get a curve and not a line. If it wasn't an exponent of 2, then it would be a line, right? Because then the degree is 1. Now this is the interesting part that maybe you noticed or you didn't notice. This y-intercept. So let's see if you again caught on. The y-intercept in the fourth case was -9, right? -9. Where do you see that? Oh, he's sitting in the back, right there. The y-intercept in the fifth case was so high up on our graph, we don't even have it on the picture, but we got it off at Desmos. It was 48. That was our y-intercept. Where do you see 48 in the equation? Oh, look at that. He's in the back. Now let's do another one. Our y-intercept wasn't on our table, wasn't on our graph because we didn't extend it, but we got it off of Desmos, and we see that the y-intercept is -10. Where do you see -10 in the equation? Oh, look at that. It's in the back spot. That back spot is called the c, right? ax squared plus bx plus c. So if you remember back to our factoring days. So the c part is the y-intercept. So whatever number is sitting here, that's your y-intercept, because remember, the y-intercept is when x becomes 0. So if x becomes 0 here and x becomes 0 here, these two terms go away, 0 plus 0. All you're going to be left with is the constant. So another way then of stating 0 comma y would be 0 comma c. That c number that's in the back of the equation in standard form is your y-intercept. So that's a good sign when you're looking at standard form that you have the y-intercept staring at you. So this guy tells you whether you open up or down, the a value, right? If it's positive, you open up. If it's negative, you open down. The c value is your y-intercept. That's pretty much it. And if you know your a value, you can work backwards and get your second differences if you wanted, for whatever reason. So again, this summarizes everything that we just talked about. A being positive, he opens up, he has a minimum. A being negative, he opens down, he has a maximum. Second degree means it's parabolic in its shape. And of course, our second differences then are equal if it's a second degree function. All right, so it's going to be very important that you work through the practice on this one and get used to these patterns, but they're not very difficult. And we'll continue with our analysis next time.